So we have someone or multiple ones joining the Zoom session. Are you currently here? So it's okay. It's okay. If you are really sitting in the back and you have difficulties, maybe you can join over Zoom. But later I will explain. It's important for you to come to the classroom so that you don't stay at home and join the Zoom session. Oh, the one just quitted the Zoom session. Okay. It's fine. It's fine. Either way, that is convenient for you. Okay, let's get started. So welcome and a very good afternoon, everyone. So this will be the course MS 5215. The full title is a bit long, called AI Enhanced Business Analytics with Spreadsheet and Python, or Excel and Python. Spreadsheet and Excel, we use the terms interchangeably. It's quite a long course, and some of you might be in the OSEM orientation where I briefly mentioned about this course. The course has been constantly evolving, as I explained. So I'll say it again. Several years ago, I've been teaching this course for 3-4 years. The first time I was teaching it, before the first time I was teaching it, there was COVID. And during COVID time, the course was called Business Analytics with a Spreadsheet. So very short name. And that time, we were still teaching VBA, so basically coding in Python. And then we realized, okay, VBA is not very commonly used anymore. Python is more popular as a programming language. So we decided to kick out the VBA part, introduce Python. And that was until last year. Starting from this year, the College of Business actually decided, okay, AI is not the hot topic. We should introduce more AI related stuff. So please don't get confused by the long name and so many terms in the title of the course. Although we have 3 terms, AI Enhanced, Spreadsheet or Excel, and Python, I would argue that they are all secondary. As a matter of fact, in terms of importance, the business analytics is 100% core of the course. So no matter what we learn, they are supporting tools. Because now AI is hot, so we are trying to introduce some of the AI elements. We can imagine 10 years from now, hopefully this course will still exist. Maybe, I would say just maybe, Excel will be outdated. Python will be replaced by some other programming languages, which I doubt. And also the AI like large models and generative AI might have hundreds of new generations. Well, they are still supporting tools, but if the course remains, the core will still be business analytics. So in short, we are going to learn business analytics, data analytics, operations analytics, whatever, by understanding the business problem involving data. I'll explain each of the keywords in a minute. So again, historically speaking, this course has been expanding quickly over the last few years. 3 years ago, when I first taught this course, there was only 1 session, smaller than this classroom. Last year, there was 2 sessions, 2 parallel sessions. And this year, guess what? We have 4. Probably benefit from the new program, AI in Business. So as a matter of fact, this year is the first year that I will be co-teaching this course with one of our other colleagues from the DAO department. Each will take charge of 2 sessions. I'll be teaching the Thursday morning and Friday session. So if you download the slides, though that is from the Monday session. So the slide for the first lecture, the slide may look a little bit different because for the self-introduction, of course, we each prepare different set of slides. So we often make jokes, right? So 1 session, 2 sessions, 4 sessions. At this rate, next year we may have 8, right? Going exponentially. But let's hope not. Let's hope not. So let me start by briefly introduce myself. My name is Han Wei. You can call me Han Wei. I'm Han Wei Li, currently assistant professor in the Department of Decision Analytics and Operations, DAO. I obtained my PhD in the Institute of Data Systems and Society at MIT, Massachusetts Institute of Technology. So I highlight the word data here. So this is absolutely the core of the course. And I also put the kind of the logo of MIT here, which I will connect back later. So has something to do related with this course. My office is at the Lau building, AC3 building, 7th floor. And my email is here. You can either, you don't have to write down the email or something. You can just search online on the CTU webpage and get my email. Also, my email also is there in the syllabus. So personally, my own research interests include data-driven operations management, revenue management, pricing, platform operations, which is a good thing because what I do for research, the topics I'm writing papers on, are quite relevant to what we teach in the course. So I'm quite comfortable teaching this course. So give you a simple example. Many of you are from mainland China, I see. In China, one of the platforms, Meituan, the little bike sharing system, the little yellow bikes. For the pricing algorithms, the pricing, particularly the discounts you receive on that platform, I'm part of the paper that designs the algorithm. So if you have a very low discount, okay, you can thank me. If you have not received any discount, that's not my fault. It's their fault. So a little bit about the course information. Of course, I changed this slide slightly for every session because we all have different time. So the formal lecture time will be from 12 to 2:50, and the room is this room. We have 3 sessions among 4 in the same room. So I know the time of the session is a bit particular because it's right in the middle of 3 consecutive sessions. I know some of you may need to finish another class, 9 to 12, and some of you join another class right after this, so 3 to 6. So one thing I want to know, so according to the university policy, for every 50 minutes we teach, we are supposed to have a 10 minutes break. So roughly speaking, 3 hours lecture, we should have, if you think about 10 minutes break, we should have 3 10 minutes breaks. But for one thing, we are required to end 10 minutes earlier. So now we have 2 10 minutes breaks. So usually my own practice also applies when I teach other courses, is that we would have 10-15 minutes break in the middle after I teach for like 80-90 minutes. Sometime around 1:20, 1:30, we will have a 10-15 minutes break for you to just rest a little bit. Maybe go to the restroom and something. And another 10 minutes break, this is something that we need to discuss. For other sessions, for the morning and night sessions, they don't have to worry about it. But for us, I want to ask you whether you prefer we start 10 minutes earlier, which is at 12:10, or we end 10 minutes earlier, which is around 2:40. Which option is better? Let's do a quick show of hand. Do you want to start 10 minutes later? Or 10 minutes earlier? Okay. If you don't show hands for both, I was a bit concerned. So let's keep the mainstream. Let's try to start on time. Although I understand it'd be challenging for some of you. So let's try to start roughly on 11 at noon. 12 at noon. So there might not be enough time for you to grab a proper lunch, but we will try to. The good news, we will try to end around 2:40. So plenty of time for you to transition to another classroom, 20 minutes break. So the office hours will be by appointment. You can write me email. We can schedule a meeting over Zoom or things like that. This will be particularly helpful if you have difficulties following the course materials. I understand that the students have really diversified backgrounds, so I will briefly talk about that. Some of you are pretty advanced because you have certain programming experience. Some of you are even from the CS background, which supposedly some of the contents here are too easy for you. But I also understand some of you have never used Python. That's okay. We assume zero background on Python, but some of you may have never used Excel before, which we understand, and we will start. Particularly for the first lecture, we will start very, very slowly. So you can write me email and do let me know that you are from which session you are from and this course with the course title with the course code, because I'm also teaching other courses. I don't want to get confused. So the course material will be mostly lecture notes and all the, for example, the Excel and Python files as supplementary materials. So there's no official textbook. If you really want to know more, learn more about either Excel or Python, here are some additional references. I think they're both either available in the CTU library or online. So the course mode is face-to-face. You may realize I was setting up a Zoom session, but that's not for you to join the sessions online, stay at home, right? I will reiterate this many times, but the nature of the course is quite different compared to some of the traditional courses like statistics and mathematics, or like a professor writing something on the board and you writing something on the paper. So it's not. And that is the primary reason why we need to use a computer lab, because this is supposed to be a very hands-on class. The benefit of coming to the classroom in person is for you to, whenever we will do a lot of hands-on and real-time exercises in both Python and Excel. So if you come to the classroom, you can try to follow up. If you cannot, it's not your fault. It's supposed to be my fault. You should raise your hand, interrupt me, and ask me to slow down. The purpose of the course is never to finish all the materials as fast as I can, but to make sure that at least most of us should be able to follow. So I plan to use the Zoom to record the lecture. So there will be recordings, but it's only available upon request for those of you who who due to some unexpected circumstances, for example, you are sick on one of the sessions. So after the lectures, you may write me email, request the recordings for reviewing. All the lecture material, including the slides, Excel, Python files, will be uploaded on Canvas. So Canvas will be our official website. All your assignments, your group project report description, even your final exam, everything will be uploaded onto Canvas. So that it will be, if you think about the course, Canvas is the website, is the place to go. So as a result, you will submit everything, including your assignment, and in the end, the final exam through Canvas, not by email. So this is supposed to be the most exciting part, critical information about this course. So in terms of the course grading, we have three formal components: the final exam, individual assignments, and the group project. The final exam counts only for 30%, which is relatively low. That means if you do well in your continuous assessment, in your individual assignment, in your project, you do not have a lot of pressure on the final exam to pass the course, right? Traditionally speaking, the final exam will be a 3-hour offline exam with the internet blocked. So this gives you some hint, right? Whatever large language model, generative AI knowledge we teach in this course, we may not be able to test in the final exam that efficiently because you will not have access to the internet. It will be on the university desktops, so this is very important. And this is another reason why I strongly encourage everyone to come to the classroom, because some of you, just like me, you may be a Mac user, right? Or you use a Windows machine for a different version of Excel or something. But your final exam will be conducted on the university desktops, which are just the machines right in front of you. So if you come to the classroom, you get comfortable working on those like everyday practices. It will be much easier for you to do things in your final exam. Typically speaking, it consists of two components: the modeling questions, which are, I think, most in Excel, and the multiple choice questions. In previous years, this course, I usually make a promise to the students. I personally do not enjoy testing coding in terms of Python, the coding questions, when I ask students to write code explicitly with their internet blocked. The reason is that if you think about myself in my daily research and work, whenever I try to write a code in Python or R, I cannot just write code simply without consulting like Google or large models. So I don't think it's very reasonable to ask you to write code without any external help during the final exam. So as a result, as a compromise, in the previous year's cases, they are like Python-related programming questions will be mainly multiple choice questions, so conceptual. If you have further questions about the formats and stuff, feel free to talk to me during the break after the class or write me an email. So there will be 4 individual assignments, which counts for 40%, which is a large amount. Again, from previous years' experience, they are all pretty easy. So, on top of that, you do not have to do it on your own. You can later you will have a project group. You can discuss the assignments with your group mates, with your other friends from the course, but you need to submit your own solution. Right, that's the only requirement. So there will be one group project which accounts for 30%. Previous years, the group project topic is quite wide. We do not set any restrictions or limitations. Basically, find a business analytics related case study and do some research and report and make a presentation. But this year, we want to add in more AI element, and we are aware that all across the world, there are many companies and business entities that have successfully implemented Gen AI or large models to make their business or operations more efficient. So this year, we explicitly require something like you need to act as a business analyst to conduct a strategic case study, finding an example or a case that you have utilized Gen AI or large model solution. So in this project, it's supposed to be qualitative, so you are not going to write any code or real implementations. So they're supposed to be easier. In terms of the deliverables, you are at the end of the semester, you are going to submit in Canvas 2 things. One is a final report, 15 pages, including everything. So really, it's not that long. And a group presentation. Right. The first year I was teaching this course, I tried to make the group presentation in class. So during the last week, I will not teach. I will make everyone present on stage. But then I realized, okay, we had too many students, so each group will only get less than 10 minutes. So it's quite in a rush. So starting from last year, and of course this year we don't have plenty of time to do that, the summation of the group presentation will be online. So you will make a recording of your group presentation. So the good thing for you, maybe you can practice several more times, but the bad thing is that you have fewer opportunities to learn from your fellow classmates. But it's good for me because I got to learn all of your cases. It will be 15 to 20 minutes, typically 15 minutes, that's fine. We will, of course, this is just a simple description, as also mentioned in the syllabus. We will release more details around week 3 or 4 when you have a project group. If you have any questions, again, you and your group may consult me. We can arrange individual Zoom meetings to answer any questions. Talking about the group, we require the group size to be at most 5. Of course, 3 to 4 people are also fine and maybe even more efficient, but at most 5 people. If you are a WeChat user, you can scan this QR code to join a WeChat group to look for teammates more efficiently. If you are not, don't worry. Canvas has a discussion session where you can post there, right? Looking for a teammate, describe yourself a little bit, background information, and interested people will reach out and leave your contact. So, and you have plenty of time to do this. You only need to form your group by the end of week 4. So roughly 3 weeks from now, you should have plenty of time to do this. So by the end of week 4, if you still cannot find a teammate or you don't bother, you want to be randomly assigned, that's also fine. I will ask our TA to randomly assign you into a group. At this point of time, the department hasn't informed me who will be the TA for the course, but I hope there will be a TA for grading purposes. So later, once we know the name of the TA, I will introduce. The TA will not be joining the class. The main responsibility will be grading the assignments and probably the exam. So if later you receive a low score or you want to argue the grading of your assignments, talk to me and I will blame the TA. So let's spend 20, 30 seconds if you haven't done so and you want to join the group. Let me check. So we had another group because this course has 2 parallel sessions. We had another group on Monday, Thursday, but of course, this is a big class. After reaching 200 people, the group cannot be joined by scanning the QR code. That's why I had to create this new group. So this group is exclusively for Friday session. Oh, I forgot to mention another thing you need to note. If you have a really good friend who's coming from another session, well, unfortunately, for easy to management purposes, you're only supposed to group with the students within the same session. So that's reasonable. That's reasonable. Let me see. Good. I see a lot of people joining. So again, if you are not WeChat user, don't worry. Don't worry. You can reach out and talk to our fellow classmates during the break or after the class, or you can use the Canvas discussion post. So this will be the tentative timeline. As you can see, the last 2 lectures, we kind of hesitate a little bit whether we want to reserve the last 2 lectures for group presentation or for teaching something new. Then after discuss with another colleague, we believe that, okay, making a presentation, it's still, we have a lot of people. So, and we want to introduce some more AI elements. So this is a tentative timeline. We do not need to, we may not follow strictly of the timeline. As I promised, if I realize that we are all slow, again, not your fault, but my fault, I should slow down so that if I cannot finish the content within 1 lecture, I will just stop and resume the next time. So it's perfectly okay not for us to finish all the topics here. Roughly speaking, for the first 6 weeks, we will use Excel, some of the very fundamental operations. And then the next 5 weeks are Python from the very beginning, from the very scratch. So having said that, let me try to better understand about your background. So how many of you have used Python before? At least, not necessarily taking a formal class, but try to understand or use Python. Not a lot, not a lot. Which is perfectly fine. For those of you who have certain experience, this will be quite comfortable. But don't worry if you have 0 background, we are supposed to teach from the start. And so you can see the last Python class will be only packages. So not very deep. So your expectation, you should adjust accordingly. And then how many of you have used Excel before? Oh, sorry, let me ask the other way. Don't be shy, it's okay. How many of you have not used Excel before, or it's the first time you use it? Please don't laugh, yes, we have some. So that's the reason why today's our first lecture, introductory lecture. Later we will try to do some simple exercise or on a real data set together. And because some of you have never used Excel before, I will try to be as slow as possible. So please do not complain if you think it's too easy or too obvious for you. May not be so for others, right? Let's try to understand. Okay. So previous years, some students asked me about the difficulties of this course. So let me quote by one of the greatest minds of all time, Albert Einstein. He once said, "Do not worry too much about your difficulties in mathematics. I can assure you that mine are still greater." So this quote is not particularly appropriate in our course because the nature of the course, as I said, is mostly practice and hands-on based. So it will involve very, very little of mathematics. Some of your other courses, you may need to understand some modeling or mathematical, statistical, probabilistic background. But for this course, I would argue that it's better because it's okay to make mistakes. We even encourage you to make more mistakes because as a practice-based course, whenever you make a mistake, you can quickly double check and correct it. This will also happen in your final exam, right? You know something does not work if error message pop out. So in general, your expectation of the course will be, of course, first, the most obviously, the analytical skills. We will introduce several supporting tools, including Python, Excel, and sometimes the large models. But I would argue that the most subtle, trickier, but the more important thing is the ability to think analytically. Again, the main purpose of this course, okay, we may give you assignments or test you in the final exam on how do you use Excel or Python, but the key takeaway, the key message of this course is always be the business analytics. I would like to bring up an example. Think of yourself as a business or data analyst in a company, and your boss throw a new data set to you, ask you to summarize, to generate a report, to draw some conclusion, to build a model, or even to provide a solution. So that is, in general, the most frequent cases in your future work or study. Once you know the tools, it will better help you to achieve your goals. But more importantly, you need to think. That's why in some circumstances, we would argue that AI can never replace human beings because as an expert, and you will be an expert, hopefully, by the end of the course, you will be able to think about the context of the data set, try to understand the data set, do some necessary cleaning or analysis, draw some insights, and make a well-informed decision. We will go to some of the details. I will elaborate what do I mean by, for example, data or business analytics in a moment. But let's first briefly talk about the tools. So first we have Excel. Many of you have been using it. It came from the word excellence. It's developed by Microsoft, part of the Microsoft Office family. So again, we are all performing the tasks on the university desktop, so Excel is by default already installed there. So you can either open any worksheet files to open Excel, or if you do not have any file on hand and you realize Excel icon is not on your desktop, just search on the search tab. In case some of you cannot find it. And then we have Python. Again, feel assured that we require absolute zero background, and we will teach from the very beginning for the Python part. Python is one of the most widely used programming language. I personally also use it a lot. It has a very big community support, many well-built libraries. And in the recent years, Python is even easier to learn. Because if you think about learning Python 5 or 10 to 10 years ago, you need to first learn how coding works and take a lot of coding exercises to learn it. But nowadays, like even if you are a professional coder, I usually talk to some of my friends. They work in the industry coding every day. Well, nowadays with the help of Cursor, some of you may know it, which is basically another version of the large generated by large models. People write code mainly from, I shouldn't say this, but roughly speaking, copy pasting the code generated by AI, and by their own understanding, update and correct the code, which is the critical because whatever AI generated might not be correct. So this will save you a lot of time and effort. So the learning curve suddenly becomes much more friendly. So I think this is a good time to learn some fundamentals of Python. So later, if you talk to GPT or Gemini to generate a runnable Python code, and you realize, okay, something is wrong, you will be able to understand and find out where it's wrong and change the code in the way you like. And of course, maybe both. Microsoft has been trying to integrate new tools into Excel. This was a piece of news 2 years ago that Microsoft integrate Python into Excel. So there's a user interface that in the formula bar, if you type certain Python code, it will do something for you. Well, it's maybe useful when you are in the overlap that you in your daily work, you use both Python and you use Excel. But I would personally argue that this is only for a few group of people. Usually speaking, people just stick to one side. But if you happen to use both, this is something that you should explore. It's quite convenient. And of course, we will briefly talk about the large models in this course. But again, manage your expectations because we are not here to teach you to understand the transformers or deep neural networks, how they work, and the theories behind them. We are mostly going to use them as supporting tools. Again, think of yourself as data analyst. I'm from the DAO department, so many of the cases I will talk about are related to, for example, supply chains. And my own research are in pricing and revenue management, so maybe sales data, and so on. We will give you more examples. And whenever we are doing an exercise, you can think of, we may not have the time to repeat all the exercises using large model, but sometimes, if you have time after the lecture, you can try asking some of the questions I asked during the lecture to the large model, see what it generates, right? So they are so powerful. So again, let me try to understand you better. How many of you have learned any of the large models before, including GPT, Gemini, DeepSeek, Copilot, and the CTU chatbot? Anyone have used it before? Good, I see around half. For those of you who have never used large models before, personally, this is even beyond the course. Personally, I strongly encourage you to at least try. At least within this course for your assignment, unfortunately not for the final exam, for your assignment, for your group project, well, you are welcome to use like the large models. To share my own experience, I used Gemini on a daily basis, mainly for two things. One is to rewrite my email. I will just write some grammarly mistaken emails and throw it to the large models, ask it to help me refine the writing. It's been doing a very, very good job. And another thing is when I work on my academic papers, I also ask me to summarize existing paper by just sending a PDF or do a literature review, but later I will talk about something like this, also help me to improve the writing. To give you a concrete example, around 5 years ago, while I was in MIT, I finished a paper. Then our team spent around $1,000 to hire a professional editor because I'm not a native speaker. We hired the editor to help us improve the writing so it looks professional. Last year I checked, the editor already bankrupt. Why? Because, of course, nowadays, very, very few people would go to the editor, spending thousands of $, because the large models can do an even better job within minutes. So again, personally, beyond the scope of this course, personally speaking, if you haven't got an opportunity to use this, at least try. Having said that, practically speaking, I mentioned 5 versions of large models, right? Some of the widely used ones like GPT and Gemini, unfortunately in Hong Kong, it requires VPN to use it. And sometimes you need a membership. So that may not be the most convenient way to go. DeepSeek, which should be available, but personally I didn't use it much because it's always busy on the server. So Copilot, for some reason, Microsoft is really friendly to us. Copilot is available on in Hong Kong. May not be available in mainland China, but available in Hong Kong. So that's one benefit we should use. So if you just Google Copilot, spell like this. The first option will be Copilot. I started use it only last week. Then I realized, okay, it's quite good in the sense that you don't need to sign in to ask questions. Right. For example, I ask a simple question: what is business analytics? Right. You should be wondering this question, right? This is the core, as I mentioned several times, of the course. Of course, I'm a human being. Descriptive, prescriptive, predictive, prescriptive. Those are the 3 components that we will also talk about in a moment in the slides. Very interesting. Also give you some real application domains, why it's important. So again, if you are not happy with the way that I will talk about this topic, of course, you can always check the large models. So this is Copilot. How many we have mentioned? We have mentioned 4. There's a 5th option, although it's not the most up-to-date model, but it's the one that is closest to us. It is the CTU chatbot. I bet very few of you know this. CTU. You can just search CTU GPT or something because it will connect to one of the GPT versions. I think it's 4.0. You will go to a CTU webpage introducing some of the popular large models. And here, if you click on the CTU portal and log in, you will happily realize that, okay, we have a CTU chatbot that give you 30,000 quota for each month. That for everyday usage, for example, you write me an email and you want to improve your writing. No need for me, no need, but to some other, or you're writing an essay for your other courses, this may help. Yes, it's using GPT-4 or DeepSeek. Yeah. So this is just another option. For this course, if we want to quickly get some answers, inputs from large models, we may probably use Copilot, since it's available in Hong Kong without the need of a VPN. So this is, what's the word? Word cloud I generated last year. I was putting the title. I mean, if this is the first time you are using a chatbot, well, usually speaking, you just treat whatever the large model like an agent that is talking to you. So the good thing about the large model is that it will remember, it has certain memories of your conversation history. So if you are not happy with one of the output, you can keep asking. Later we will use some certain examples when we go to Excel. But last year I was just talking to GPT. I was teaching this course called help me generate 30 or 40 keywords so I can generate word cloud. So sorry to let you down, but we do not have all the time to introduce all the topics here. Some are quite deep. TensorFlow, Seaborn. Well, Seaborn is fine. Deep learning, neural networks. We won't go that deep, but some essential topics we will be briefly talk about. Like for example, in Python, we will probably use Jupyter Notebook and so on. Excel, statistics. So this goes back to the question of what is business analytics. As I was trying to ask Copilot, you remember it generates 3 core components, right? Prescriptive, predictive, I forgot the first one. Descriptive, predictive, prescriptive. Which is quite surprising because this is the answer I generated just now, also when I generated last week. But when I prepared the following 10 slides also, the following 10 slides also was generated like several years ago. At that time, GPT did not answer like this. So I'm happy to see whatever I prepare become the official answer for GPT. So, but to answer this question, it generates a rather long paragraph, and you might not be bothered reading. So I'm going to motivate you by taking the analogy of certain philosophical questions. I'm no expert in philosophy, but I think this is something that everyone should be interested. By Paul Gauguin, like this should be the 3 questions that the most fundamental questions we think of as human beings, right? Where do we come from? What are we? Where are we going? Unfortunately, the purpose of today's course is not to answer those 3 questions for you, and I cannot. By the way, this is an illustration by this artist that is in the Museum of Fine Arts in Boston. Nice place. So that's why I'm using the analogy of the 3 fundamental philosophical questions to help you understand better what is business analytics by decomposing the 3 components. So the first component is where do we come from? So if you think about the starting point of business analytics, it all started when we began to collect data. It may happen back 30, 40, or even 50 years ago. When we start to gather data and we have more and more data, the first thing that people tried at that time was to generate some summary, generate some report to help them better understand the data. And this is often referred to the descriptive analytics, which will include, for example, business reporting, using data visualization, using summary statistics, and of course, data management, data warehouses, and so on. So people, because the amount of data is accumulating very fast, and people need to rely on some simpler terms and reports. For example, if you have a very long sequence of numbers, you cannot get insights from taking closer look to each and every individual number. Usually speaking, you need to rely on some summary statistics, like taking the average value, measure the standard deviation, and so on. Later, we will briefly talk about this part. And combined with data visualization, make certain plots and graphics, figures, it will help you better understand the data. So the first step is always try to understand the data, combining the contextual information. And usually we call this hindsight. But later, people are not satisfied with the first step, right? As you can imagine, once we have enough summary, we have enough reports, people are trying to take one step further to ask the question analogous to what are we? Think of this as, historically speaking, as if we are mathematicians or physicians. We observe something like Sir Isaac Newton. We observe apples falling down from the tree to the ground. And we are trying to formalize this with a ground of like physical laws to explain why things work like that. In the analogy of the data world, this will evolve something called predictive analytics. And if you see the list of topics, they are probably the hottest topics in the past maybe 20 years and in the foreseeable future. It includes statistics, econometrics, data mining, forecast, and last but not least, machine learning. So in short, at this stage, people are trying to build models, mainly mathematically, to explain what is going on to try to understand or to try to simulate, not simulate, but try to investigate what is the underlying data generating process. So the purpose is always more accurate, higher accuracy, and more explanation power. So this is the second stage, which is for most of the cases we are right now. And this is all usually referred as insights. So you want to draw insights, you want to explain the data you observe. You want to capture the noises. But this is not the end. This is not the end. Well, you can argue, and sometimes, again, I'm from the DAO department, and I work in the field of management science or operations management. Sometimes we think highly of our field for this simple reason. Because we are not satisfied with only building models to explain the facts. We are trying to take one step further to ask the next philosophical question is, where are we going? So the core of our field is that once we have certain insights and understanding of how the system works, how do we improve it? The term is called optimize, means that we are trying to make more well-informed decisions. It makes sense, right? After you build models to try to explain how the data come from, you need to do something about it. Otherwise, you are just wasting your resources. So here, in the last step, we care about make better decisions by utilizing the data, which involves a lot of optimization, including decision trees, simulations, expert system. And this is called foresight. So this is about the past, the present, and the future. We are trying to make our future decisions a better process. So now if we go back and take a closer look at what the answer GPT generated or Copilot generated, answering the question of what is business analytics, we have a better understanding. Again, you don't have to need to go through all the detailed descriptions, but you can always think of this as the analogies to the philosophical questions. And also, it will give you a lot of application domains, which I assume many of you will be working in your career life. So it is quite important. So in short, turns raw data into insights and insights to better business process, business decisions. So you can think those three steps in a coherent framework. In fact, the importance of data, I'm going to use the next several slides to reiterate the importance of data. Here I borrow another quote from our great Sherlock Holmes. He once said, "It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts." Well, if I cover the name, I would say, okay, maybe a mathematician or at least a physician said this, but yeah, from a detective. So sometimes you can compare investigating a new data set as a detective job, right? You want to find the patterns behind this and eventually reach your ultimate objective. So another case which might be less familiar to many of you, this is Edward Deming. He's widely thought of one of the founders of the field of operations research. After World War II, he kind of utilized data, building the operations research tools to, again, to in some extent, make US one of the most successful countries during that period. He said, "In God we trust, all others must bring data." But if you think nowadays, those are all very old examples. If you think nowadays, this is the picture I had online, telling you that how much information, how much data are being generated every minute. We are talking here. So the challenge sometimes, so there are two challenges here. Actually three, let me put in three. So the first challenge is the huge amount of data. We need the computation power in many cases, to be able to even read in those data, right? That's the first challenge. The second challenge is, of course, whether do we really need all of those? Because so much data we generate every day, I post, the posts I write online, the comments I leave online, I would say 99% of them are useless for business analytics purpose. So we should be able to identify the useful part among all the huge amount of data. That's the second challenge. And most importantly, the third challenge, if you think about the traditional data formats, like how many products I sell for each day, or what is the price I set for the products, they are all numerical. They're all numbers. So in the past 20, 30 years, people have been working in the research field to develop mathematical tools, like in statistics, like in machine learning. The most fundamental tasks in those fields are helping us dealing with numerical data inputs, which is good, all very, very good. However, the new challenge in recent years is that the format of the data has becoming more and more various, right? So if you think about nowadays the data formats, apart from the numerical data, we have more and more text data, right? The post. We have video and image. So the amount of information contained in the videos and images, if you think about each and every pixel, is imaginable compared to the numbers. So the traditional tools will not work anymore. And that's why in machine learning, they have this very, very, very popular field in the past 10 years also called computer vision, right? And that's for the image and videos. And for text, you know what? Because we have so much text information online, and imagine if you can have a machine or a system that can gather all the text we ever know and generate some text according to the statistical patterns. Well, that would be nice. Well, I'll tell you that is actually how the large model works. We will explain that in a minute. So the third challenge, and I repeat here, are again, because the data are in new formats, the amount of information it contains is not in the same order of magnitude. So that's some new challenges. We cannot only rely on mathematical tools, although having said that, in this course, some of the tools we deal with are quite fundamental, most numerical. And more challenges are on the way. We don't know in maybe 5 to 10 years what are the new challenges for our data analyst. Right. I'm going to briefly pause here to see if there's any questions for two things, for overall course information and for the motivational examples for business analytics. So again, I want the class to be interactive. Although we are a pretty large size class, but if you have any questions, I'm perfectly okay. I encourage you to interrupt me and ask a question, because the rationale is that if you have a question, it's very likely that some other classmates will have similar questions. So it's very helpful for you to ask, because in many cases, I won't be able to know. Again, it will be my fault, not yours. So you should ask. And according to some previous year's comments, sometimes I tend to speak a bit fast. So if you feel like, okay, you are going too fast, either in the way I'm speaking or in the way I'm doing the exercises, slow me down. I will not be offended at all. So, any questions at the point? Of course, if you feel a bit shy, you can talk to me individually during the break after class or by email. Okay then. Then we will use the next few slides. Although I promise you there will be only a little bit of mathematics in this course. In the first lecture, as a courtesy, I should help you refresh your memories on some of those. Again, My statements in the following several slides may not be mathematically rigorous, but they are useful enough for us because in business analytics, the more important thing is not rigor, it's insights, intuitions. So if we think about the first stage of descriptive analytics, again, think of yourself in an example where your boss throw to you a new data set. What will be the first thing you want to do? Of course, before you try to generate complex models and stuff. So I would argue, later I will show you some real data sets and discuss in a real case, but I would argue that first, it's not trying to generate summary statistics. This is one of the beginning steps. But first, you should try to understand what the data is about, which is called context. Right? So without understanding where the data is coming from, what it represents, you cannot draw any useful conclusion. But nevertheless, we'll talk about that later. Nevertheless, I will use the next few slides to help you, again, to refresh your memories. I believe all of you have taken related course on probability and statistics. When we talk about descriptive measures in terms of summary statistics, again, you have a very long list of numbers, and you do not feel like you do not bother taking a closer look to each and every one. You need to rely on some mathematical forms to gather the information. So here we first introduce several summary statistics in terms of measures of center. And today I will give you an example, and later we will use that in Excel. Let's think about the wage or the income distribution. Right. Later we will see the data set. So suppose I have a list of numbers where each number is a particular income or wage of a certain person. Then your boss asks you, okay, I give you a list of numbers as a data set. What you get from the data set? One of the first things you can do is to obtain some summary statistics. For example, computing the average, computing the mean, computing the mode. And we can do all of this in Excel. We will do that together. So hopefully you still remember what each of those represents, and I will explain it here again. Mean, in this course at least, we are using several terms interchangeably. Mean, average, and formally speaking in mathematics called expectation. Those three words are the same thing. It measures the average value of a distribution. That is mean. And then we have median. So if you arrange all the numbers from the smallest to the largest, sometimes we care about the middle point. What do you mean by middle point? It means that 50% of the observations are higher than that value, and 50% are lower. So it's right in the middle. The third one is mode. It's relatively less frequently used. It represents the most frequent number. The most frequent number. Interestingly speaking, as you can see from the two plots, if a distribution, like the way that different value spread, distribution, if it's symmetrical, then often the case we have the three measures of the center coincide or very close. However, if it's asymmetrical, means that it's not the same from the left to the right, then you will observe different measures of centers in terms of the three quantities, which is also easy to understand if you think about the case of income distribution, right? In this case, you can think of this distribution as the income distribution. It's always skewed in this direction, because if you think about the outliers or the to the end, there are always very few but very rich people, but a lot of people like I'm not gonna say like us, but relatively poor people. So in a sense, the mean value will always be higher than the median or the mode. Why? Because there are certain rich people like Elon Musk out there. When computing the average value, averaging across the billionaires, the average value will be driven higher But if you think about median, we do not care about the extreme values of people who are extremely rich or extremely poor. We only care about the 50%. In other words, Elon Musk make another billions of dollars tomorrow, it will not affect the median. He's still richer than the 50%, right? And in terms of the mode, it's the most frequent number. So in the income distribution, it's likely to be to the lower end, right? Because we have more people in poverty. So that is the example of income distribution. So and the difference of the three measures. Well, borrowing another quote from our Sherlock Holmes, he once said, you can, for example, never foretell what any one man will do. But you can see with precision what an average number will be up to. Individuals vary, but percentages remain constant. Again, sometimes I suspect, other than the author, he's a certain mathematician or statistician, right? Because the rationale or the spirit behind this quote is essentially law of large numbers or even central limit theorem, right? And this is why the power of data size kicks in. When we have a data of a very small size, for example, only 2-3 people, we cannot draw useful conclusion because they are not representative enough. And when we get thousands or even millions of observations, then according to the statistical properties like central limit theorem, then we start looking at the mean, median, and mode they each represent will tell us some useful conclusion. As a matter of fact, again, this is not very important in this course, but maybe in your statistic course, this bell curved shaped distribution, many of you know is called normal distribution. The reason why it's a normal distribution, just because of the central limit theorem. The larger the sample size you have, the closer, usually speaking, your summary statistics will go to a normal distribution. And of course, facing a data set in terms of the summary statistic, sometimes you are not happy with only the measure of center, right? These are the three measures of center. Sometimes you care about the extreme points. For example, when we talk about the wage or the income distribution, we care about the maximum and the minimum point. People love to talk about on the news who is richest person in the world, right? Or the top richest person, people. And on the other hand, we care about the minimum income because, for example, in the US, the minimum wage is defined by the law. So it's really necessary for us to find out in the data set what is the maximum and minimum. And also the discrete measures also should include the measures of variation because only by relying on the center, the lowest point, and the highest point will not tell you that much of information if you do not discuss the measure of spread or the measure of variation. So in statistics, this is called a second moment, not important. And equivalently, we may use either standard deviation or variance. So to give you a concrete example, this is going to be the exercise we will do later in Excel. Once we have a data set, one of the first things we should consider doing is to generate a summary statistic table. As a matter of fact, this is also the thing I need to do when I write an academic paper. So if I need to introduce a data set in the paper, I will first explain how the data set is, where the data set comes from. For example, it comes from a certain platform, a certain company. Then, to be academically professional, I need to provide an accurate table like this for each feature here, like wage, education, experience. What is the average value? What is the maximum value, minimum value, standard deviation, and sometimes the percentile. And of course, before all of that, how many observations do we have? So I assure you this is the professional exercise you need to do. It will give your reader, in our case, our bosses, a much more clear understanding of the data set. And here we have several things we didn't talk about before. The quantiles, and sometimes we call percentiles. Similar stuff. So following my previous thoughts, if we arrange the data from the lowest to highest, they form a distribution. If we cut the distribution in half, 50-50, the middle point is called a median. But it also has another name called 50% percentile. We know it's by definition by its name, right? Also, it has a third name called the second quantile. So if we try to understand from the English perspective, the word quantile, quant means 4, means that we are splitting the data into 4 equal pieces. Each accounts for 25%. So as a result, we will have the first quantile, which is the 25% breakpoint, the second quantile, which is the median, 50%, the third quantile, which is 75%. Okay, that is quantile. If you are splitting the data finer into 100 equal pieces, the English word is percent, so we call it percentile. So we have the same thing, the same concept, but different names. 25 percentile, which is the first quantile. 50 percentile, which is median. Again, 75 percentile, which is the third quantile. Right. It is worth noting that we have a term. You don't have to memorize all of this. If you consider the center 50% of the data, which usually speaking are the normal ones we usually care about in a data set, the distance between the third quantile and the first quantile is called the IQR, interquantile range. This term is particularly useful when you are trying to make a data visualization like a box plot. So here is an example of a box plot. Some of you may have learned this before, but for many of you, it might be new. In a box plot, represented by its name, we have a box. The length of the box are just the interquantile range. So in other words, the box will cover Q1 to Q3. And there's a line in the middle of the box which will represent Q2, aka median. Outside the box, which means that we are outside the middle 50% of the data, we would have 2 line segments extending. So by definition, we are extending by the segment length of 1.5 times IQR. Why is 1.5 times IQR? Well, it's according to certain common rules, or at least taking the analogy from normal distributions. Again, you don't have to remember this. We will generate the plot together later. So Q1 minus 1.5 RQR, and Q3 plus 1.5 minus RQR. So typically speaking, if a distribution is normal or like bell curve, this line segment together with the box in the middle should cover more than 99% of the observations. So whatever is beyond, like smaller than Q1 minus 1.5 RQR or larger than Q3 plus minus 1.5 multiply IQR are taken to be outliers. In our previous income example, they are extremely poor people or extremely rich people that are supposed to be beyond 99%. But of course, the distribution will not be strictly normal, so 99% is just an estimate. So again, you can by data visualization, you can explicitly see the size of the interquantile range in a box plot. So again, I said many well-behaved distributions, especially in terms of summary statistics, they behave like normal distribution. So if we think of a normal distribution, the box plots are defined in this way. So again, the box captures the middle 50%, and the line segments together with the box should cover more than 99%. And in case we have outliers, we will use individual little dots to represent them on the plot. Again, you don't have to memorize all the details, just to showcase in our first lecture how sometimes data visualization tools can be combined together with summary statistics to give you better understandings. This is not, like box plot is not the only correct way for you to visualize a single series, right? Sometimes there are other rules. This is one of them, like the Six Sigma rule. Again, assuming the data is normally distributed, we compute the mean value, which is called mu, and we compute the standard deviation. If it is a normal distribution, then 2 sigma, roughly speaking, will capture the middle 2/3 of the data, around 68%. 4 sigma means plus or 2 standard deviation should capture around 95%. Surprisingly, 95% is the most widely used cut point in statistics. 95% confidence interval, right? And 3 sigma or 6 sigma means plus minus 3 standard deviation should capture more than 99%, 99.7%, which is supposed to be the main body. Everything beyond that should be pure outliers. Right. So having said about the income data set for quite several times, now I think it's a good time for us to take a closer look. So if you haven't done so, please go to, again, if you never use Canvas before, it's a good time to get familiar with the common operations. So if you haven't done so, please go to Canvas. Under Files, there's a folder called Week 1. Well, under Files, there is our syllabus. So if you have any questions about the general information about the course, take a look at the syllabus. So under Week 1, there's an Excel file called wage. We will be doing some practices in that. So Canvas has a lot of other functionalities, for example, people. So if you already find your teammate, you can go to people and register yourself under, I think it's under student group. You can try under project group Friday. I'm not sure if you can do that. If you cannot, just register yourself in the student groups. And later, I will, once we have our TA, I will ask our TA to assign you. But for now, let's go to Files. And download the Excel file called wage. Any technical difficulties opening the file or downloading the file? If you cannot find the file, I think for the automatic downloads, it should be in the download folder. If you cannot find it, after you open the PC on your desktop, it's under downloads by default, unless you manually download to somewhere else. And also a side note, in case that is the first time you use the university desktop, it's quite convenient, but one of the worst thing is that every time you shut it down, it will erase all the memories. So this is quite important. I will repeat multiple times, especially during the final exam, because there's a possibility of a technical difficulty. So sometimes if you work on the Excel file for like more than 1 hour, then it is, every year it happens. Then Excel crashes or the computer just shut down, you will lose everything. So the best practice is to save your files frequently, especially Excel. I'm not trying to scare you, but it happens. So after you open your Excel file, again, for those of you who are your first time using Excel, let me spend like maybe 1 minute or two explaining, right? We have different functionalities as bars or ribbons on the top. And on the bottom, we have different, we can call them spreadsheets or we can call them tabs. So it can contain different data sets or different practices, which you will find useful. And in the middle, this one is called a formula bar. Usually speaking, whenever you are trying to fill in a cell, you can directly type in. But if you want to generate something using a function or something, you should use this formula bar, and later we will do the exercise together. So don't worry if it's your first time using Excel. We will start very, very slow. If you think I'm still too fast, let me know. Let me know. But before that, let me briefly tell you about this data set. As I said, like maybe 30 minutes early, if a boss gives you a data set, the first thing you should ask is the meaning or the context of the data set. So in other words, maybe two things. So the first thing is how the data is being generated. What does each column represent? So this question has not been properly answered. If I just give this data set to you, you may have confusions, right? What does it mean by EDUC, EXPRN, wage? Or you can make a reasonable guess. Maybe the wage represents income. But you still do not have all the information. For example, if I don't tell you, you will not know what unit. Or more importantly, what are those people? Are they in the US? Are they of the current age? Are they living in the current era? If that's so, the wage is pretty small. And what is the unit? Is it US dollars? Is it thousands of US dollars? Without those information, whatever conclusion you draw is questionable, right? So the first thing we need to know, context. And also, that is why in many of the cases, professionally speaking, whenever you are working on a data set, a must-have thing is called a data dictionary, or at least some side comment for each column. It will explain to you what is this column representing, and within a data dictionary, usually it will spend several sentences explaining to you how the data was collected. In this case, let me briefly introduce. This dataset is one of the most widely used and famous dataset in the field of econometrics. When I was learning my PhD econometrics course, we used this dataset. So it has more than 500, scroll down, more than 500 observations of a very old survey of people's income. So we have 5 columns. The first column is hourly wage in US dollars. The second one is years in education. Third one is years of working experience. Fourth one is an indicator or binary variable of whether the person is like gender, whether the person is female or not. And the fifth one is whether the person is married. So why is this example or data set so famous? Because historically speaking, as econometricians, they care, and we should care, about this terminology called return of schooling. Right? This is everyone in education should care about. People care, people generally ask the question, if we spend one more year in school, in learning, in education, will that on average, pay attention to the term on average, increase or decrease or has no impact on our wage? So this question should be the interest to me and also to you. If the answer is no or negative, then everything we do here is questionable, right? So if I'm telling you spend one extra year in the university will lead to a lower income on average, then you may get pretty frustrated. So this data set, at least at that time, I think this more than 30, 40 years ago, or is trying to investigate that. So to do that, it has more than 500 observations of their hourly wage in US dollars, years of education, years of working experience, their gender, and marriage status. After knowing the context of a data set, usually speaking, the second thing you need to know or you need to think is whether the data is in a good format, or in other words, standard format. Different people or different industry may have different standards, but the most common standard or requirement of a standard format of data set is that, I will repeat this many times, so don't worry. Each column should be an individual feature or variable. Each row should be an individual observation. So to some extent, this data set is already standard format. We see each column is an individual feature, wage, education, so on. And each row is an individual observation. So if you have a very messy data set that is not individual, for example, the rows are the wages, education, and the columns are different values, different observations, then it's okay, still okay for you to perform some task, but in the field of data analytics, we won't say that's very standard. People in general, we don't like it. So that's just one common standard to set. Before we dive in, okay, it's already 22. Let's take around 10 minutes break. Come back at around 35. In the meantime, if you have any questions, come talk to me. Okay, let's resume. Okay, let's continue with the Excel exercise and explore more about this data set. Roughly speaking, we may face different types of features. For example, in this data set, it consists of 5 features. The first 3 are so-called numerical. They are numbers, to put it simple, right? And if you want to categorize it further, the wage is a continuous variable or continuous feature. It can take fractional values. But the years of education and the years of experience, at least in this data set, they are integers. Not very important. You can treat them all as numerical variables. What is different is the last 2 columns. They are sometimes called categorical, and sometimes, in this case, it's a binary variable. So let me explain a little bit the difference between the numerical and the categorical. Numerical is easy to understand. They are just numbers. We can deal with the numbers in whatever mathematical or statistical tool we have, for example, computing the mean. Categorical is usually the thing that people don't like that much because it will bring complexity. But the truth is, in the real world data, we sometimes, in many cases, we face a lot of categorical data. In this example, it's a special case. Categorical means that there are a discrete set of pre-specified options we can select from. Or in other words, there are only several answers to the question of that feature. If there are only 2 outcomes, and sometimes you can think of this as a yes or no question. If I ask you a question, instead of what is your gender, if I ask you a question, is your gender female, the question, usually speaking, can only be answered by yes or no, at least here. Right? So in the US, maybe it's a bit more complicated. If a question can only be answered by yes or no, it means that it can only have 2 outcomes. And numerically speaking, we often convert the yes answer to 1 and the no answer to 0. And in data, we call it binary. So if a variable is binary, it's very standard and we like it. And in this case, we have 2 binary variables. One is an indicator of female. So for example, our first observation is a female. So it's 1 means the answer to the question whether it's a female is yes. And 0 under the column married means that the person is not married. So and so on. Right. Oh, so before we continue, I forgot. I received 2 very excellent questions during the break, and I should elaborate. So the first question is about the class participation. If you take a look at the slides when we talk about the course assessment, class participation is not a formal component of your grade. However, I'm going to again claim that attending in person is very important, and being interactive, for example, asking questions, is also very important because in some cases, for example, if your final grade is between 2 letter grades, for example, B plus and A minus, in that case, there might be rooms for adjustments, considering that all 4 sessions together, we have more than 320 people. So it will be helpful if you answer questions frequently, better if I can remember your name. This will also be beneficial because I need to go through all of your group presentation recordings, right? When you are making your presentation, if I say, okay, I remember the student, I will have a good impression, and somewhat your group score may be higher. So the answer to the question is no, it's not a formal component in terms of participation, but I do encourage you to do so, and it will make the course more effective. The second question is about Python. How do you install it on the university desktop? So the topic is a bit early because for the several 5-6 weeks we will be learning Excel. But if you are interested, let me quickly show you. On the university desktops, you can either later when we learn Python, we are going to use probably most likely Jupyter Notebook, which is you can think of a notebook in writing Python code, and it will run it for you. So for both the Python and Jupyter Notebook, we can use later. I will give you two options, either offline or online. Offline means that you use the university version, and it's actually very convenient. On your desktop there should be an icon called here, Work Desk. Double click Work Desk. There are a list of softwares you can install. Again, we are too early to say this. After lecture 6 or lecture 7, we will visit this again. So don't worry. Just a heads up for some of you who might be interested. So if you search for Jupyter Notebook and for Python, you can install them by a single click. After the click, the installation will be automatic. After a few minutes, you can use it. Same for Jupyter Notebook. If you search for notebook, right, Jupyter Notebook. Again, we are not going to use this in the next maybe six lectures, but when we start talking about Python, I will teach this again. That's the second question. Only for those of you who want to explore. For the online version, Jupyter Notebook actually has the online version. You just Google it if you want to know it. Again, you do not have to install Python on your local machine, which turns out to be quite efficient. You do not need to install anything on Jupyter Notebook in the online version. So we'll probably teach Python in the online version. Any other questions? And appreciate all the questions I received during the break. You should ask more if you have any doubts, or write me an email. So let's continue the discussion on categorical variables. So we mentioned binary variables, which are essentially a yes or no answer to a specific question. But more complicated speaking, what if we ask a question that can answer by more than two answers, right? More than two options. What if I ask your favorite color, right? It cannot be only two colors, right? So if we have a data set, an extra column, let's say the favorite color, which contains more than 10 different colors, then we begin to have troubles. Because the traditional ways of computing average and stuff can only apply to numerical columns. What do we do then? We will spend more time talking about this in the future, but just to give you some heads up, let me use another more popular example. Because colors, there are so many different colors, I cannot even count how many are there. Let me use another more popular cover people like to use nowadays. I think in recent years, people love to use MBTI test, right? There are in total 16 types. Correct me if I'm wrong, I'm not an expert in it. So suppose we have a new column called MBTI, and we know there are in total 16 outcomes. So the column is purely categorical and text-based. They are not numbered, they are text. So how should we pre-process the data so that it becomes standard and numerical? This question is very, very hard. But let me just do a spoiler for you. I'm now making a claim that for a categorical variable with, let's say, 16 levels, make a guess. How many columns do we need to convert them into binary variables? If you understand what I'm talking about, good. You can try to make a guess. If you do not get the question at all, don't worry. We will talk about it in details in the future lectures. Again, let me repeat my question. So before the question, let me give you an analogy. The genders, we have two outcomes, male and female. And we need a single column. I'm not going to explain why, maybe later. For MBTI, we have 16 types. How many columns? Why? What's the name? Well, that's more advanced than we need. What's the name? Well, so as suggested, we may need 4. The argument is a tree-like structure, right? But in a standard data format, the columns should be independent. So what you are suggesting is machine learning is more advanced than we need. It's too much beyond the scope of the course. Any other guesses? We probably need more than 4. That's the. So we need 16 or a single column? To each number. And then we have a single column using the 16 different numbers. Well, that's one option. For example, if we have a mapping, what's your name? Fei. Fei suggests that we have a mapping, for example, 1 represents a certain type and 2 and so on. Then we can use only a single type. That is one option, actually. In the other sessions, none of the students in the previous session suggested this way, but actually this is a viable way. So very good, very good. But the approach I'm going to suggest is a little bit different, because I have one extra requirement suggesting that we should, in the outcome data, the columns should be binary. In other words, each column should only have 0, 1 output, which in some sense, I mean, your question is very good, but if it's all 0, 1, in some cases, it's easier for us to process. For example, let me show you. If it's 1 to 1, 16, then if I ask you a simple question for a specific MBTI type, what is your type? I mean, what is your MBTI type? Just going to use as an example, yeah. It's okay if you not to share. Let me use my own. I forgot. ENTJ, okay. Let's just take this as an example. For a specific type like ENTJ, that's a type, right? If I want to ask you, I'm your boss now, I'm asking you, how many people in the group are with that specific data set? Then you need to apply a specific function. For example, if that type corresponds to number 7, you need to use a count-if function to count how many, in the column, how many numbers equal to 7, right? So that's why I'm saying your suggestion will be working quite good. But what I'm going to suggest is that we will need 15 or 16 columns to convert each type into a single column, right? So if I ask the same question again, how many people are in that specific type, we just sum up the 0, 1s in that column, because 1 means that you are in the type, you are that type, 0 means you are not. Again, if you don't quite follow this set of argument, it's fine. It's just an introductory lecture. But the point I'm trying to make here is that, do we really need to use 16 new columns? This is something related to something like a degree of freedom. So I'm going to make an argument that we only need 15. Anybody see why? Very good, very good. Yeah. I'm trying to see whether it's coincides. So taking the analogy here, starting from the simplest case, marriage status or gender only have 2 outcomes. But here we only need 1 column. We do not need another separate column called male. For the simple reason, because that column of information will be redundant. Because once we know the value for this column, the other column is not important. We do not need to know. It's redundant. Because they are mutually exclusive. If the value or the binary variable for female is 1, then for male it has to be 0. So that is the reason why for 2 outcomes we only need 1 column. Again, this is more advanced, so if you don't quite follow, it's fine. We will probably revisit this. And for the MBTI example, we have 16 types. Imagine for the ENTJ. Let's set ENTJ as a so-called basis. So we completely forget about ENTJ. For all the other 15 types, we make an individual column for each. So if I observe she's type is 0 for all the other 15, then we know for sure she's belong to the type we did not mention. So the general argument is that for a categorical variable with x or n, let's call it n features, we only need n-1 binary columns. The final column we can omit because they are redundant. Again, this is pretty slightly more complicated. but that's the spirit. Okay, let's go back to the fundamental ones. Let's try to write some functions and try to compute the summary statistics. Yes, exactly. Again, to summarize what I claimed, for if we want to expand, right, for a categorical variable who has 16 different outcomes, sometimes we feel like it's not easy to process. So as a result, we want them to be separated in separate columns so that each have very nice behavior of only 0, 1 outcomes as indicators. And we know for sure if we have 16 outcomes, they should sum up to 1. You belong to 1 and only 1 type. So that's the reason why we only need 15. Because knowing the first 15 values will give you the definite 100% information about the 16th number, right? If you are that type, we omit. The first 15 0 will give you the final 1. And the 1, we do not have to spell it out. So the good thing about this data transformation is that now that everything is not categorical, is not text, we don't need a dictionary to code all the types. So they are all 0, 1, and the column names will indicate each type individually. But what is the trade-off? What is the downside? The downside, of course, your data has 15 more columns. If you have 100 categorical features, each with 10 levels, 10 different outcomes, you essentially will expand this to a standard format of more than 1,000 columns, which is still okay for us. We should, in many cases, do that. So end of the example. Let's go back to the fundamentals. So the first practice is try to get some summary statistics of the first 3 categorical values, or categorical features. Let's start with count. Usually, we can just scroll down to the end of the data set and see how many observations are there. But you can achieve this together with other functions for some other summaries, like data summarizing tools. So for those of you who is your first time using Excel, I'm going a bit slowly here. So let's empty the cell. So in this cell particularly, we try to count how many observations are there in the wage column. To do that, we will need a function. A function is like a certain tools that help you achieve specific goals depending on different function names. So we will go to the formula bar, and whenever you are trying to insert a function, you start with the equal sign. So equal. Without equal sign, you are just typing the content. With the equal sign, you are trying to compute or generate something using a function. So the function we are using here will be count. We will encounter quite a number of functions within this course. You do not need to remember all the names and their exact usages. Only for the commonly used ones like average and so on. So the function name is called count. We only need to type the first few letters. Compared to the other data analytical tools, Excel is arguably the most user-friendly one because the learning curve, it's easy to get it started for many reasons. One of the reasons here, if you try to type in a function name, it will try to guess which is the function you are trying to use. And if the function name is quite long, you do not need to type in the full name, just use this autofill. So for example, count is the function that we are going to use. You don't have to type in all the letters, just use the tab key to autofill the full name. So again, a little bit of short key optional. You don't have to use it, but it will save you some time, maybe. So after the name of the function, usually it's followed by a parenthesis. You can call it bracket, parenthesis. And within the parenthesis are the so-called arguments or inputs that is required by each function. Usually, most functions will require certain inputs, right? If you think of a function is you apply a tool to a part of the data, within the parenthesis or the bracket are the part of the data you should specify. So specifically to this count function, we need to select the range that this function will help us count how many numbers, how many observations, how many occurrences in that range. So we can select the whole column. Note that the first row is not a numerical value. It's called the wage. Sometimes we call it a feature name. Sometimes we call it a label. After you select the range, you can hit enter. And it will give you the answer of 526. So we know there are 526 observations in this data set. So the next useful tip for using Excel is copy pasting. Because let's suppose we want to fill in all the counts for all the 3 variables. Well, the dumbest way is, of course, to manually type the same function name 3 times, but of course, no one will do that. One way is to do copy pasting. Again, Excel is being user-friendly. If you copy paste, it will automatically change the selected area. For example, from this cell to this cell, we are trying to, if we do a copy paste by, you probably know the short key, Control-C, Control-V, or manually copy paste. I'm just doing here because we have other ways to do this. You realize that it's not the same formula again. From column A, which is wage, the formula now is being automatically updated to column B, which is education, exactly what we want. So again, Excel is trying to automatically update the formulas unless you freeze the cells. We will talk about freezing, use dollar signs and short key F4 in a future lectures, not today. This is one way to do it, copy pasting. Or alternatively, you can do copy pasting by simply dragging. This is more easier. This is easier. So if you select a cell you want to copy paste and you go to the, let me put it bigger. You go to the bottom right of the corner until your cursor become a little dark cross. And then you can drag in either that direction you want to copy paste. If you drag to the right, it will autofill the remaining cells by updating. If there's no dollar sign in the expression, it will try to automatically update your formulas. You can also try dragging downwards, but it will not give you the correct answer because dragging downward is computing the same count, but in the cell below, we're trying to compute something else. So be careful when you are doing copy pasting because sometimes you will make mistakes. Excel will make mistakes, not you. It will try to guess how should it update your selected area, but sometimes it's just not doing the correct job. Okay, that's for count. Let's compute the average. So again, let me first get rid of this. Similarly, the function name we compute average is just called average. In other languages, it may be called mean or something. That's why I'm saying that those different terms means the same thing. Mean, average, expectation, they pretty much all mean average. So the function name is average. Again, you do not have to finish typing all the letters. Just use the tab key. So again, for average, it will compute. You will select a range of cells containing numbers, and it will compute the average value for you. So again, we can select the first column. Or alternatively, we can manually select all the numbers within the first column. Here, let me quickly teach you another short key. If you want to select up to the last observation of the same column or the entire selection area, you can select the first cell. In a formula, it's usually color-coded. Here is blue. And then the short key is Control-Shift downward key. This is optional, by the way. If you want to manually do all of the things, perfectly fine. The beauty of this course is that it's practice-based, so usually there are different approaches that will lead you to the same answer. And in many cases, there are more than one correct answers. So again, the short key to select the whole region until the last row is Control-Shift downward key. You press Control-Shift and you hit the it will try to automatically select all the existing values within the same column. So similarly, if you want to select the entire row until the last, because here is a space, so it cannot skip this. Similarly, it's Control-Shift-Right. If you combine those right and down, or down and right, you select the whole area. So again, this is just a short key. You do not have, it's purely optional. You do not need to use this, but it's efficient. So again, let's select all the wage observations and hit enter, which will give us the average hourly wage in US dollars for this data set. So after we get the number, we can immediately start thinking about update our belief, update our knowledge about this data set, right? On average, the hourly income in US dollars is less than $6, which is possible because this data set is very old. And you can drag and double check. Okay, it's computing the average years of education, average years of experience. Years of education between 12 to 13 years, years of working experience, 17 years. Similarly, we can use other functions to compute other summary statistics. For example, standard deviation. Here, I'm not going into details of different versions of the same function. For example, for standard deviation, this is the default, but old version Excel one. If you know more about statistics, there are two versions of computing standard deviation. One is called .s, sample standard deviation. The other is .p, population standard deviation. Again, our first lecture only introductory. We will use the default without anything, just stdev. Again, you do not need to remember the name. It will compute the sample standard deviation. If you still remember from your statistics class, population and sample standard deviation are slightly different by a degree of freedom. And because technically speaking, we are treating a sample, so if you have time after the lecture, you can try using different variants of the same function. If you use .s, the sample standard deviation will give you the same answer, while population will give you a different one. So let's just use the standard one. So again, you can drag. So again, after you get every little piece of summary statistic, you can try to interpret what does it mean and whether everything makes sense. This is very, very important because making sense is according to your expertise, not the tools, right? I would argue that everything makes sense here because the variation in terms of years of education are small. Because relatively speaking, people more or less receive the similar years of education compared to their working experience, where the variation is much larger, simply because different people have different career plans, career path, right? And then we can apply a different set of functions, including the minimum, which is min, apply it to the same area, minimum, 25 percentile. Again, I'm not going into details of each and every one of them. So recall that 25 percentile, which is also the first quantile, in Excel, the function percentile will take 2 arguments. Actually, you can know the argument after you type the parentheses. Excel will give you a hint of what are the arguments you should put in and in what order. So by the hint, by this little tag, you realize, okay, I need now 2 inputs. One is the array or the data. The other is a so-called K, which is the percentile. If you are still not sure, because this tag is too short, it does not contain all the information about this function. If you want to know more about this function, go to formulas. On the top, go to formulas. There's a button called insert function. If you click insert function, it will try to explain to you in more details the formal documentation of the usage of this percentile function, current function you are using. You see this function, I mean, the font size is a bit small here, but I hope you can see it on your own machine. This function returns the kth percentile of values in range. Array is the data, and k is the percentile between 0 and 1 inclusive. Not important whether it's inclusive or exclusive. But we know it's a number between 0 and 1. So this saves us the trouble of thinking, okay, whether I should put 25 or 0.25, right? So for the 25 percentile, we should put 0.25 as we do here. Similarly, for median, we can use the same function, but it's just the 50 percentile. The third quantile is just 70.5 percentile, and the max is just the same as mean. So I'm going to skip some of the details. And last but not the least, the mode is just the function name is just called mode. We will probably revisit and reuse some of the very commonly used functions in the future lectures. Again, this first lecture is only supposed to be introductory. Some find it already very familiar, but some maybe it's first time. Don't panic. And we usually, as I mentioned in the slides, we usually combine summary statistic table with data visualization tools because there are certain limitations. You might often hear sometimes that summary statistics may be misleading. For example, if I give you a number of the average income, it may give you the false impression because there might be outliers, the super rich people that drive the average value up. So to some extent, we may argue that the summary statistics, because they're only summary, we may lose part of the information. So what if instead we want the whole picture? We want to give you a sense, a more direct sense of all the data instead of only a summary. Often we use data visualization tools. In Excel, it's often called either figures, charts, or I forgot the third name. They are used interchangeably. So specifically, if we want to know more about the wage distribution, the first column, how is everyone being distributed on the number line? We may have different visualization tools. The first one is called a scatter plot. This is useful especially to answer our very first question. If we have two data series or two features, we want to plot their pairwise relationships. For example, we are curious, right, whether a longer years of study in school will positively correlated with our income, right? To do that, we may plot a scatter plot. By its name, you can probably guess what it does. So each individual dot in a scatter plot represents a single data observation. So by making such a plot, we are losing no information. We are truthfully reflecting all the information we have in that column. So again, whenever you are trying to generate a scatter plot, because scatter plot is a pairwise, we are caring about wage and years of education. We select the two columns first, then we go to insert. Again, we will revisit some of the data visualization tools in one of the future lectures. So under insert, there are recommended charts, and we can try see if Excel can guess what do we want. So the first one is appears to be a scatter plot. And click OK, it will generate. Right. You might not be happy with this plot. What? You can argue, well, it's not very informative, it's a bit confusing. I don't know the X, Y axis. Also, I maybe want to swap the X and Y axis because now apparently the Y axis is the years of education. We want to put it the other way around. And the title, yes. Yeah, but the title here is education, so I suspect that this is, yes, I'm sure. The y-axis now is the education because this is the second column. Usually what Excel does is that, a very good question, let's double check. Let me select only the first observation and my insert. Scatter. No. You can see the y-axis is, no, not this example. Let me redo the scatter plot. Well, what's your question again? I may understand it wrongly. Yes. Yeah. The reason of the education being the title, because Excel, we will explain in more details in the future lectures. Excel is trying to guess what are you trying to plot. So it's kind of, because we have two features on the x-axis and one on the x-axis and one on the y-axis. Usually speaking, we care about how the y-axis is changing according to the x-axis. So we care about y-axis more. And that is the reason here the y-axis is the education as the second column. So that's why the automatic title generated by Excel is using the y-axis, which is education years, as y-axis. That is also the reason why I said we may not be happy with this plot because we care more about the wage, the first column. So if you want this plot to be more natural, you should swap the x and y axis and change the title, of course. So how do we do that? Well, it's not straightforward, so I will teach you in the future. And also a side note, you can generate better plots much faster by copy-pasting the data into a large model. You can try it if you want after the class. Scatter plot is not the only way. If you only care about, for example, the wage distribution, remember in the slides we talk about the box plot, right? Let me get rid of this one first. So again, we select the first column and we go to insert. Let's try recommended charts first. So box plot will summarize a single data series in terms of its distribution. Well, unfortunately, Excel is not that smart. It does not give you our targeted box plot. So in that case, we need to go to the all charts and manually look for the chart we want. So many different types. We will have the opportunity to mention some of them. And we will choose towards the bottom called box and whisker. So again, the default generated figures and charts in Excel are in many cases not very informative and not very professional. If you give this chart to your boss, well, your income might be lower next month, right? Because see, there's no title, there's no legend, there's no. I mean, we have a series name called one. What is that, right? So to be professional later, we will do all the required things. But at least we know, not sending to our boss, within ourselves, we should have a better understanding of the distribution of the wages, right? Again, the income are usually skewed towards the left side. So we only have outliers on the richer side, not the poor side. Because there are extremely rich people that are even beyond our 1.5 quantile range. And you see here is the box of the interquantile range. The line is the median. And this little cross does not appear in the slides. This little cross, sometimes we add in to represent the average or the mean value. And in this case, the mean value is higher than the median, indicating that, okay, we have outliers on the top. Right. So always keep in mind, whenever you perform a task, after you are done, it's not finished yet, you need to think what insight you can get from those, right? It will be helpful. Apart from the box plot, you may have other ways. To visualize the data, specifically for a single data series, for a single feature. So here we're going to introduce one thing called histogram. How many of you have heard, not used, but only heard histogram before? Oh, it's Okay, some of you. It's quite it's smaller, it's fewer than I expected. It's fine, it's fine. We will formally introduce this again, probably in the future. A histogram, you can think of a histogram like a frequency table or something like counts for number of occurrences according to pre-specified intervals, or formally we call them bins. Combining this example, I think is easier to understand. We generate a histogram. This is a histogram automatically generated by Excel. It will first automatically define the bins, like the small intervals. For example, the first interval are from 0.53 to 2.13. So for each interval, and all the bins should be equal size. For each one of the interval, Excel will help you count the frequency, or in other words, the number of occurrences or the number of observations that belong to that bin. And then it will draw, it's like a bar plot, but the height of the bar represents the number of occurrences or the number of observations. So the higher the bar, the more number of observations belong to that interval. So again, if you are familiar with probability, this is somewhat similar to a probability density function, sometimes called PDF. If you already forgot, never mind. Just similar, not the same thing. So there are more than 3 to 4 different ways to plot a histogram in Excel. This is one. Automatically generate, you select the column, you go to Insert, Recommended Charts, Histogram. This is the first way. But you may not be happy with this automatic histogram because the bins are automatically decided by Excel. Sometimes you want to specify your own intervals, right? For example, from 0 to 2, 2 to 4, 4 to 6, and so on. Remember, the bins has to be equal size. So in the next tab, I'm going to quickly show you, this is the practice of user-specified bins. And within the user-specified bins, we have 2 different approaches. Use different functions. Right. For example, you are the user, and you have specified we are using this as the breakpoint. 2 means below 2. 4 means from 2 to 4, and so on. Right. And again, you are trying to manually count for each interval how many observations belong to that range. To achieve this, you can use 2 different functions. So again, within this course, we only care about for the operations, we only care about whether you can successfully do the job. In many ways, in many cases, we have different approaches that can do the same thing. We are not going into details of this COUNTIF function. It may seem a little bit complicated. So again, you do not have to remember the usage of this. But at least you should understand the insight or the intuition of why we are doing this, right? For example, reading from this long, ugly formula, you can imagine we are trying to count within the data range, the blue area, how many cells are larger than 2 and smaller than 4. Something like this. So this is one approach. A more direct approach is to use the function called frequency. Because we have already pre-specified all the bins here, remember I said the histogram is like a frequency table. So the function frequency will help us in that way. So let's try to do this together. Let me delete this first. There are multiple ways to use the function frequency. We can use this frequency function as a grouped function. To use a grouped function, we first select all the area that we want to generate the output. Again, this is not compulsory. If you don't follow this part, it's fine. First lecture anyway. You select the whole area you want to fill in. You type the frequency function, the first few letters, and then autofill the frequency function. Then again, as hinted here, you want two inputs. One is the data, first column, right? Separated by comma. If you have multiple arguments, they are separated by comma. Then the second argument are the bins, which is the selected area in red here. After making the two selections for a grouped formula, instead of enter, which you may do, if you hit enter, it will automatically fill in, but also after that, it will be counting the number of larger than 26. That's one way to do it. Just hit enter. Alternatively, you can do this. Let me do it again. Frequency, data, bins. You can hit Control Shift Enter. That will apply the formula to all the cells for the selected area only. Either way is fine. Pick whatever is most comfortable with you. So in that case, after you hit Control Shift Enter, you realize the formula has an outer bracket, indicating that you are applying this function to multiple cells in the selected area. Right? So again, if you're a bit confused about this part, it's fine. It's fine. After all, we are going to introduce 3 to 4, maybe at least 4 different ways to generate a histogram. You only need to know one of them, which will be enough. If you have questions, we can discuss later. And you can visualize this by a bar plot, which we'll talk about in around lecture 3. And then let's briefly talk about correlation, because when you have multiple series and you are interested in their relationships, in their trends, correlation is a good statistical measure. I suppose many of you have forgotten what is the definition of correlation. Here I'm being very hand-waving by telling you the intuition that correlation is a numerical value that is between -1 and 1 that measures two data series in terms of their relationship, their tendency. So the closer to 1 means that they are more positively correlated, means that if one series is increasing, we would expect the other one increasing as well. I'm being very cautious here. I'm not making any causal argument. I'm not saying that one increasing will lead to the other increasing. I'm just saying if we are doing prediction, we see one increasing, the other we should expect them increasing as well. On the other hand, if the correlation is close to -1, if one is increasing, the other should be decreasing. If it's 0, then we cannot predict one's behavior using the other. They are said to be uncorrelated. So we can generate a so-called correlation table, measure the pairwise correlations for the data set we have, for the numerical columns we have, only the numerical. So let's do this. So first, we go to data. On the right side, there's a little button called data analysis. This is kind of a little package of tools that will come in handy if we want to do some numerical analysis. So after clicking the data analysis, we realize, okay, there are many very useful tools if you are working in statistics. For example, some hypothesis testing, regression, random number generation, also including histogram. So if you are interested in generating the histogram in another way, try this after the class. But here we are trying to generate the correlation. Where is it? Okay, here. So a separate window pops up. It's like an independent tool. We want to manually select the data area and some other related settings. So for the input range, which is the data we need to specify, we will click this little button to manually select the data. right? This little button will give us the power of manually select the first 3 columns, which are the ones that we want to compute their correlations. And they are grouped by default, as I say, the standard data format. Each column should be a feature. So by default, it should be grouped by columns. And we need to tick this little option, labels in the first row, because in our data set and in the most standard format of data sets, the first row usually are the column names, aka labels. So we tick this, labels in the first row. And we can also choose where we want the output correlation table to be printed. We can manually select the output range, or by default, it will generate the output table in a new worksheet. So we click OK. In a new worksheet, it is. For the diagonals, they are all 1 in a correlation table, because if you compute a correlation of a data series with itself, they are exactly the same. They are perfectly correlated. Yes? Completely. Yes. Yes, exactly. So that's not very informative. So the numbers that we will be interested in are the ones on the bottom triangle, like these 3, pairwise correlations. Roughly speaking, our simple conclusion is that we are quite happy with the result, because there is a 0.4 correlation between education and wage. At least it's positive, and the value is relatively reasonably large, larger than working experience. Right. So usually we first take a look at the sign. If it's positive, I mean, they're positively correlated, their tendencies are towards the same direction. And interestingly, we find out that the working experience and education years are negatively correlated, about minus 0.3. Well, the reason is also straightforward. For a person that spent more years in school, relatively speaking, he or she will spend less years in working. So a negative correlation makes sense. Right? So this is usually how we generate, using various tools, generate the output and try to interpret. That's the most important step. Last but not least, we can do some simple analysis on the binary variable. By simple, I really mean it, because binary variables can only take output of 1 or 0. So everything is pretty much standard. For example, for the column female, we can do a count. How many of the observations among the 526 are female? So we do a count. Again, we use the COUNTIF function. If you are not familiar with the function, ignore it. We can use COUNTIF to count how many in this data set are female. Similarly, how many are married. We can also do some very simple calculations while it has certain meanings. For example, if we take the average value of the column, we get a number of 0.48. Who can quickly tell me what does it mean by this 0.48? Yes, shout it loud. Percentage of what? Exactly. So to help you better understand, this might be straightforward for some of you, but not be clear for others. When we take the average value of the column, this is why I say the binary variables have the best property, because it can only take 0 or 1. When you compute the average value of the column, 0 does not contribute to the average. Only 1 will contribute. So as a result, the 0.48 basically means that the percentages in this data set of female is, roughly speaking, 48%. So that is one interpretation. So later you will find out, this is one of the many benefits of standardized a data set in terms of the categorical variables or column or factors. And later we will see more examples. So it's now 30, and I want to reserve some of maybe the last 10 minutes, briefly talk about, this is something new from this year, briefly talk about some background as an introduction of large models. Again, the purpose of this course is mainly about data analytics, not about understanding how large model works. So that's why I only use 10 minutes or less. Try to explain to you. I myself is not an expert in machine learning or the neural networks. Because why bother understanding how it works when we can directly use them, right? So at the most basic level, again, not rigorously speaking, large models are statistical pattern recognition and prediction systems. So if you think about our human beings speaking, while I'm speaking a few sentences. From the bottom to the top, I use letters. Letters consist of words. Words consist of sentences. And combining with logic, I make my arguments. Large models work in a similar way, but using different foundations. The most basic units in large models is not a letter or a word, rather they call them using a terminology called token. Roughly speaking, on the basic versions of like GPT, comparatively speaking, one word is approximately 0.75 tokens. Several letters, in other words. So tokens will consist of sequence. The reason that we do not use the same expression, instead sequence here does not mean sentences in our humans perspective, because the machines are treating them with no per se logic or emotions per se. Token will form sequences and then will form a larger unit. So the basic version of ChatGPT, if it's not a pro version or something, slightly more than 4,000 tokens. You can think of this as a memory. Yes, they have memories. They have certain memories to include the tokens. That's why when you talk to a chatbot, it will remember what you said before that make you think that they behave like human. And the more recent versions have much larger tokens. But of course, sometimes you need to pay for them. Many of you may think, okay, this is so magical. How come in many cases, large models, when we talk to them, they behave like human beings? Well, sorry to let you down, but I believe they are far from human beings like emotions and logical thinkings. What they did was simply based on the context and based on the large amount of the data they've been collected and understanding the context and then predict what is the next word it's trying to speak. And the context is usually called corpus. So we may have the impression that the large models will understand the meanings of what we say, but that's, technically speaking, that's not the case. To give you an example, when the large model is trying to generate a sequence saying something like, my favorite color is, based on all the data or the huge amount of textual information it collects, and based on the context, which is the conversation, the previous speech you and it communicate, it will try to statistically predict what is the next word. People, when the historical data explicitly mention something like, my favorite color is, statistically speaking, it will followed by colors, not by something else. Well, you may argue there are some strange tags. Maybe someone will write on the internet, my favorite color is hamburger. But statistically speaking, that's very unlikely. So in a sense, what the large model generates will be consistent with our understanding. So that's why sometimes they are doing a better job in many tasks. Because if we think about as human beings, we have emotions, we have logic thinking. The large models, what is the biggest merit, the biggest strength, is that they have the huge amount of memory that we cannot even imagine, right? So statistically speaking, after collect enough information, it will generate, according to a probabilistic distribution, what will be the next word. This is called the next word prediction. And this is also the reason why if two people ask, for example, GPT, the same question, it's possible you get different answers. Even if it's the same user for me to ask the same question twice, it's also possible for me to generate different words. Because for one reason, the context or the corpus might be different. For another reason, this is statistical. So there are certain randomness in the output. that is also the reason why sometimes large models can seem to be creative. Sometimes it generates results that surprise people. But fundamentally speaking, it generates nothing but a statistically probable answer. So whenever you think it's being creative, it just means that our knowledge is not broad enough to cover all the aspects, right? So large models are particularly useful in the following items, at least when it's firstly being introduced. Nowadays, it's evolving every day, so maybe next year it will do something that we cannot imagine for now. For example, identify similar concepts from similar different disciplines. If you work in an interdisciplinary area and you are not the expert in certain areas, consulting large models will give you some insights. Generate diverse narratives, help with ambiguity and role playing. When it's firstly being introduced, those are the most suitable tasks. We cannot say for sure in the future, but historically that is. Having said all of those good things, I have to warn you, this is out of pure responsibility and out of my own experience as well. Do use with great caution for multiple reasons. For the first reason, if you over-rely on those large models' output without thinking about it yourself, in the long run, your thinking ability would deteriorate, but that's not the biggest part. Sometimes, as we say, it does not enter the real application. It only generates statistical possible outcomes. So as an expert, you need to double check. You need to double check and make sure that the output is useful in your context. Your context and the large model's corpus is not the same thing, usually. And also, because everything is probabilistic, if you want to do some fact check. For my own experience, when I'm trying to write a paper, I ask GPT to improve my writing. It's doing a very, very good job. If I ask to help me do a literature review, generate some relevant papers, the output is amazing. But surprisingly, guess what? If I try to really look for those papers, they're all fake. They're all made up. The titles, the authors are all quite relevant. If I search on Google Scholar, none will exist. So that's very, very frustrating. So especially you will become professionals, be aware of this. I believe they will fix it someday, but at least make it better, but you need to be cautious with whatever you are using, right? After all, they are not people, not yet. The final two slides, I'm going to go very, very quickly. A brief history of how the large models was introduced. Actually, it's quite new. Around 22-ish. At that time, GPT was firstly introduced, but not a blast at that time yet. I think it was not until sometimes GPT-4 that everyone began to realize how powerful they are. Actually, the company OpenAI, I knew this company many, many years ago. I think back in 2017. Well, the company, many of you may not know, there was a popular game called Dota 2 or something. This OpenAI company was designed, bought to play that game and beat all the professional players back in 2017. At that time, no one expect the company will do something that will be commercialized as successful as GPT. But after the successful story of GPT, all the big companies, including Google, Microsoft, OpenAI, and a lot of others, Meta, they all follow up. After all, the big tech companies have their huge data pool to train the models and computational power. So some are worth mentioning include Copilot, of course, we'll probably use that. Does not need a VPN here. Gemini, which is the one I personally use the most for research purpose. Cloud, I never used it before. GPT, sometime I use it. Of course, DeepSeek, very, very popular. And nowadays, it's also updating on a very frequent basis. But very, very recently, GPT-5, just last month, was introduced. But it's not that surprising compared to GPT-4, but still, every time they will claim they will do something. At least in some certain areas, it make a huge improvement. So again, if you want to know more about what you should use, you can explore more, or feel free to discuss with me. Apart from this, the general course related questions and others, you can also talk to me. I will be now it's 41. I'm 1 minute over time, so I will let you go. If you have questions, I will be staying around for another maybe 10 minutes too. Yes. We have someone